Hello everyone, welcome to 811 day 2. Today we're going to talk about a property of our polynomials called end behavior. Alright, so our goals for today, we want to use information about the leading coefficient and the degree of a polynomial to determine what the end behavior of a polynomial is, and then we want to understand the difference between linear factors, roots, x-intercepts, and zeros. So we're going to be seeing these words quite a bit throughout this unit, and we want to make sure that we understand how to differentiate between these things. They're very similar, and yet they have some subtle differences that we need to talk about. All right. So let's get to this idea of end behavior here. So when we talk about end behavior, what we are talking about are the ends of the polynomial. So a polynomial essentially has two ends, and when we talk about their end behavior, we're talking about whether or not the polynomial goes up or down in the end, right? So as you go off to the right forever and ever and ever, does the polynomial go up or down? And as you go off to the left, does the polynomial go up or down? Okay, so we have some options that happen, right? So the possible outcomes here for our end behavior are up, 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 down, 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 and down, up. All right, so let's take a look at a quick example here. So this is a pretty basic polynomial. This is this is a polynomial that has a degree of 2 because we can see two linear factors here. So we are going to have a degree 2 polynomial. All right, so this is going to create a parabola. This is a shape that we are pretty familiar with, and if you think about what a parabola looks like, it looks like this. Right, so we get that U shape, and when we talk about the ends of a polynomial, we're talking about these things, right? So as I go to the right, this polynomial is going to go up. Right, so it's going to go up like this, and over here as we go off to the left, the polynomial is going to go up. The other possibility for a parabola is that it's upside down, right? If it's been reflected, we get a parabola that kind of looks like this, and then when we look at the ends of that parabola, it's going down and down. Okay, so let's take a look at this parabola. We can actually tell what the end behaviors of a polynomial are going to be based on the leading coefficient and the degree of the polynomial. Okay, so recall in the last video that we could see the leading coefficient out here in front of the parentheses, and when we don't see a number in front of the parentheses, we get to assume that it's a 1. Right, so that is a positive leading coefficient. So you'll notice here in this column, they want to know whether or not the leading coefficient is positive or negative. So in our case, since the leading coefficient here is a positive 1, we would say that the leading coefficient is positive. Okay, and then over here, it's asking if the degree is even or odd. Well, since we had two linear factors, right, the x minus 2 and the x minus 5, this would indicate that the degree is 2, which is an even number. Okay, so when we have a positive even polynomial, the end behavior is going to be up, up, right? So we would have an up, up end behavior. All right, so if I were making a quick sketch of this polynomial that we see here, we know that the ends are going to be going up and up. We can see from the linear factors, since we have an x minus 2, we're going to have an x-intercept at positive 2 and another one at positive 5. Okay, that's just based on these guys right here. Now we know that this polynomial is going to go up, up, right? So we're going to have one end of our polynomial right here going up and another end of our polynomial here going up, and then we would have to come down like this to go through our 0, and then eventually we would have to come back up through our other 0 and meet our other end. Okay, so this is a shape, right? So this is the shape of our polynomial along with the x-intercepts and the end behaviors set correctly. Right? So again, when we talk about that end behavior, we are talking about the ends of the polynomial, right? So this particular part of the polynomial right here. Okay, so let's give it another try. We've got a second polynomial here. It's a little bit different, so let's see what's going on with that. So we'll kind of reset our graph over here. Let's start anew. All right, so let's start with the leading coefficient again. So if I'm looking at the leading coefficient for this one, the number out front of the parentheses here is a negative 2. So we have a negative leading coefficient, so different from the first one. And notice that we have 1, 2, 3 factors, which would indicate an odd degree polynomial. Okay, so this is a negative odd, and when we have a negative odd polynomial, what we are going to have is a up-down end behavior. Okay, so this is going to go up on the left and down on the right. All right, and we can tell from the linear factors, since we have a factor of x minus 2, we'll have an x-intercept at positive 2. So I'll go ahead and plot that point. And then we have x plus 2, so we'll have an x-intercept at negative 2. And then we'll have another one, we have a factor of x minus 3, so we'll have another x-intercept at positive 3. So I know that my polynomial is going to come down and it's going to go through these x-intercepts. And since we are starting up on the left, I'm going to go to the left-hand side over here, and I'm just going to draw a little up arrow, and this represents the end of my polynomial on the left side. And then on the right side, so I'm going to be down here, we're going to be going down on the right side. Right, so I drew in my end behaviors. So I'm going to go to my end behavior here, and I'm going to come down, right, because I got to hit this x-intercept, and then I have to come back up to hit this x-intercept, and then I have to come back down to hit this x-intercept, and then meet up with my other end behavior. Okay. And again, just to make sure we understand where those end behaviors were, right here and here. Okay. So again, just a little recap on that problem. When we see that negative odd situation, we're going to have an up-down polynomial for the end behavior. All right. So let's try it again. This time we'll reset our graph one more time. And let's look at our third polynomial here. Okay, so again, my leading coefficient is the number out front of the polynomial. So we have a negative 2, so we have a negative leading coefficient. We have, it looks like 1, 2, 3 factors here, but notice that this factor has an exponent of 2 on it. All right, so when we have an exponent of 2, that means that we take this thing and we multiply it by itself. So really what we have here is negative 2 times x plus 3 times x plus 3 times x plus 1 times x minus 1, really? So really what we have are 1, 2, 3, 4 factors, right? So this is kind of a tricky disguise here. It looks like there's 3 factors, but because of that exponent, it's telling you that this x plus 3 happens twice in the polynomial. So we really have 4 factors. So this is going to be a negative even degree polynomial. And when we have negative even, we're going to have a down-down end behavior. Right? Which kind of makes sense, right? Because when we had a positive even, it was going up, up. Well, a negative out front of any polynomial is going to flip it, right? It's going to reflect it over the x-axis, so those up-ups would go down, down. All right. So let's get a quick sketch of this one. We are going to have x-intercepts. We have an x plus 3, so we'll have an x-intercept at negative 3. So we'll say that's about right here. And again, when I'm doing these quick sketches, the goal is just to get the shape and the x-intercepts on the graph. And now what we're kind of adding in is this end behavior stuff. All right. So notice the next factor is also an x plus 3, so that x-intercept is at the same place. And we'll kind of see what happens at that particular point. There's a weird behavior that happens there. All right, so x plus 1 means that we have another x-intercept at negative 1. So we're going to have an x-intercept here. And then x minus 1 means we'll have an x-intercept at positive 1. So we'll have another x-intercept here. And remember, we're going down, down. So I'm going to draw in my end behaviors. All right, so there's my 2 end behaviors. Down, down, down on the left, down on the right. All right, so here we go. So I'm going to start at my end behavior. I'm going to come up. I have to pass through this x-intercept. But one thing you should know, we're going to talk about this later on in the unit too, is that when you have 2 factors that repeat themselves like this, so if there's a repeating of a factor, it means when we get to this x-intercept up here, rather than passing through it, we're going to bounce off of it. So we're going to go up and bounce off just like that. And then we're going to go down, but we do have to make a turn because we have to come back up to the negative 1, and this one will pass through, and then eventually we have to come back down to pass through the positive 1, and we'll meet up with our other end behavior over here. Okay, so this polynomial comes up, bounces off the x-axis, and then turns around here somewhere and comes back up through the negative 1, and then turns back around, comes back down through the positive 1, and it goes down on the left, down on the right. Okay. All right. So these last two polynomials, we're going to do a couple more here, but these last two, they're not in factored form, and we don't really need to get in factored form. It's just I want to see if we can get the end behaviors from these two polynomials just based on their degree and their leading coefficient. Okay, so no need to do a quick sketch on these ones, just let's see if we can figure out the end behavior. All right, so from the standard form, right, so this isn't factored, we look for the highest exponent, right? So if I want to know what the degree of a polynomial is, I look at the exponent. So in this case, we have a 4 and we have a 2. The highest exponent is the degree, so this would be a 4th degree polynomial, indicating that it is even. Okay. The leading coefficient is found as the coefficient of the highest degree term, so that would be the x to the 4th. And since there's no number in front of the x, we get to assume that it's a 1, which is a positive number. So this is a positive even, and we've seen that before, so that is going to go up, up. Okay. All right. Now, this last polynomial, so we're going to do the same thing here. So again, we look at the exponents. It's in standard form, so I have a 5, a 3, a 2. This one's got a 1. So this is the highest exponent that we see. It's a 5th degree polynomial, which is odd, right? 5 is an odd number. And then the number attached to that term there, right? That coefficient on that particular term is a -6. So the leading coefficient is negative. And we've seen a negative odd before, so this is going to go up, down. So there we have figured out end behavior, several different formats of polynomials. We went in factored form and in standard form to determine that end behavior. So we're just going to kind of summarize these different outcomes for the end behaviors here, right? So when we had an even positive polynomial, we went up, up. Okay. When we went even negative, right, we realized that negative is going to flip things, right? So this is going to go down, down. And then over here, right, we saw the odd negative in our examples up above, and with the odd negative, we went up on the left and down on the right. And the only one we didn't really see from our examples up there was an odd positive situation. And in an odd positive situation, these are going to flip around. Okay, so that means we're going to have it down, up. So down on the left, up on the right. Okay. So this is a good table to use when you start running into problems on MyOpenMath or on your tests or your quizzes. This is a really good reference right here. You can quickly look up what your end behaviors are going to be using this table. It's got all 4 of the possible outcomes here for you. All right. All right, so let's move on to the second goal that we want to talk about. We want to talk about the difference between roots, x-intercepts, and factors. Okay, so we've talked about this relationship before in yesterday's video. We talk about these roots, or what we call zeros. Right, so these two words, roots and zeros, are interchangeable. They mean the same thing. They're essentially the numbers that create zeros in our polynomial. So in other words, if I were to input these numbers, they would output a 0. That's why we call them zeros. In other math textbooks, they call them roots. So either one of those are the same thing, but these correspond to our factors. So for instance, if I have a root or a 0 of positive 1, I'm going to have a factor in my polynomial of x minus 1. All right. Same thing if I have a 0 of -2, that means I'm going to have a factor of x plus 2. So you kind of see positive 1 leads to an x minus 1, -2 leads to an x plus 2. All right, so another factor that's going to be in my polynomial here, right? I've got a -3, which means I'm going to have a factor of x plus 3. And if I have a factor, a 0 of positive 4, that means I'm going to have a factor of x minus 4. All right, and they call these specifically linear factors, right? So make sure you recognize that this is a linear factor. A linear factor has an x in it. Okay, so hopefully we can see that relationship between those two things, right? Now going the other direction, let's say we know a polynomial has these linear factors here, right? So if I have a linear factor of x minus 5, that means that my zeros, right, the zeros or the roots of the polynomial are essentially going to be whatever value of x makes a 0, right? So if I put a positive 5 in here, 5 minus 5 makes a 0, right? So it's going to be a positive 5 for the 0. And again, you see that opposite relationship happening. All right, so if this is x plus 6, a 0 is going to be -6 because -6 plus 6 makes a 0. And same thing for this one. If I have x minus 7, then we're going to need a positive 7 for a 0 because 7 minus 7 is 0. Okay. So let's take a look at some of the polynomials. We want to be able to quickly find the roots, the zeros, the linear factors, and the x-intercepts. So let's take a look at this, and you'll see that it says see the graph, right? So we're going to go to the graph, and we're going to find the locations where this thing hits the x-axis, right? And those will be our x-intercepts. Okay, so I'm going to go to Desmos, and you'll notice I've already got the polynomial here graphed. I've got the 3 that we're going to look at typed in. You can do this on Desmos on your own too, but we're specifically looking for where this thing crosses the x-axis. Right? And we see one here at -5, and we have another one at 0, 1, 0, and 4, 0. So let's go write those down. Right? So we have x-intercepts at -5, comma 0, 0, comma 0, 1, 0, and 4, 0. Right, so we had 4 x-intercepts, which makes sense because we have a 4th degree polynomial. And now the x-intercepts and the zeros, they're essentially the same thing, just not as coordinates, right? So we're looking at the inputs or the x values of our x-intercepts to find the roots. So the roots are going to be -5, right? And then I go here, 0. Then in this one, it's going to be a +1 and a 4. Okay, so there's our roots and zeros, and then we can write our linear factors. So if I have a 0 of -5, then we're going to have a factor of x plus 5. And if I have a root of 0, then we'll have a factor of x plus 0. You could do x minus 0, or you could just do x, doesn't matter. And then here we have a +1, so we'll have x minus 1, and then we have a +4, so we'll have x minus 4. Right? So you see the difference here, right? The roots are different from the x-intercepts in that the roots are not written as coordinates like the x-intercepts are. And then the relationship between the roots and the linear factors is that they are opposites, right? So if I have a -5, I'm going to get an x plus 5, so forth and so on. Right? So let's try another one. We've got g of x here. Again, we can see it's a 4th degree polynomial, so we should see 4 roots, 4 linear factors, and 4 x-intercepts. All right, let's see what we get on Desmos. So we're looking at our second polynomial here. Get rid of this one. And let's see what we've got. So we've got 1, 2, 3. I see 3 x-intercepts. But remember, when we see this bouncing behavior, right, that means that 2 of the x-intercepts or 2 of the zeros were repeats, right? So we're going to have 2 of the same factor. That's why we get that bouncing feature off the x-intercept. So there really is 4 x-intercepts. It's just one of them happens twice. Okay. So let's get these written down. We've got -3, 0, 0, 0, and 3, 0. Okay, which means the roots, right, are going to be the x values of these things. So we've got -3, 0, and +3. And remember, this one happens twice. And we can tell because when we look at the graph, we see it bounce off the x-axis rather than pass through. Okay, so now I'm going to write my linear factors. So we would say x plus 3, right, because we have a 0 of -3, and then we have an x minus 3, and then we're going to have an x plus 0, but we're going to have it twice, so I'm going to put a square on it. All right, let's do one more. We've got h of x here. This will be the last one that we do today. So let's go back to Desmos. I've got it already typed in here and see what we are dealing with. Okay, so we see 1, 2, 3 x-intercepts again. We have a 4th degree polynomial, but we only see 3 locations where it hits the x-axis. And again, that's because we see that bouncing behavior here. So when we bounce, that means that this particular 0 or root happens twice. All right, so we've got -1, 0, and we got 2, 0, and 4, 0. Right, and then my roots, right, or the zeros are going to be right here, the x coordinates of these things. We've got -1, 2, and 4. Okay. And remember, the -1 happens twice because of the bouncing behavior, so we're going to have x plus 1 twice, so I'll just square that. And then we have a positive 2 here, so that means we're going to have a factor of x minus 2, and then a positive 4 would lead to a factor of x minus 4. Alright guys, so that is it for today's lesson. I think I covered everything we need to cover there. If you have any questions, let me know in the Zoom chat. I'd be happy to help you out. Alright guys, have a great day.